So good afternoon, everyone. Today we are going to start with the programming. Okay, last class we have written the OR-gate program. So let us start with the program. Okay, so this what we have designed in the last week. So we have given the entity name as OR-gate. OR-gate is an entity. Okay, the OR-gate has two inputs and one output. So library function what we are going to use here is the 1164 library 1164. Okay, so entity OR-gate is port A and B, two inputs and one output, and with the entity name what you have given here, it will be and with the same name. And then architecture we are going to use is the behavior architecture. Okay, in behavior architecture, same entity what we have designed here. Okay, same entity we will use here, same entity name, and the begin and the architecture body. This is architecture body. Why implies A or B? We want to design an OR gate here, so just we are writing OR here. Or here, the things what we are saying in the blue is the keywords which cannot be used as an entity name. Okay, so the things library is the blue word. Okay, this is the keyword. It is defined in the library. You cannot change this or you cannot use as entity name. It's user defined. Okay, so here that's why I have written here you can see R. So that's why I have written R underscore get. If I write only R, it will become blue. So that means blue. You cannot be the keyword cannot be the entity name. That means user defined name. It cannot the user cannot define it. Okay, so let us save this after completing this program. Let us save. Then after saving, it will show you it's completed successfully. After complete successfully, we'll go to the synthesize part. Okay, synthesize. You have two parts here: implementation part and the simulation part. In the implementation part, we are going to perform synthesizing. Okay, so in synthesizing, we will first perform view RTL schematic register transfer logic. Okay, here you can see for how much seconds is it running. Okay, okay. So what are the signal? Add all things we are adding here. So OR gate. Okay, here you can find OR gate. Create schematic. So this is the entity name. So this is my OR gate with. So let us see the complete view. Let us see the complete view. So here is the OR gate. So input, two inputs and one output. Okay, so you can find the OR gate here. So next thing is after generating the RTL schematic, you can view technology schematic and interior schematic. Okay, this is the same thing, technological schematic. Okay, so which is A and B with the buffer you can find. Okay, this is what you have. So equation whatever you want, you can give to table. So this is what the truth table is. K map. This is the K map. Okay. So this whole thing you can find here. Okay, later we'll go to the simulation part. In the simulation part, first thing what we have to give is we are giving we are not giving the test bench here. Okay, we are giving the inputs from the keyboard. Okay, so in the simulation, okay, we'll go to the iSim simulator. We are using iSim simulator here. So you may have iSim simulator or you may have multi-sim. So let's go to the behavior syntax check. It is done. Okay, so the syntax is perfectly fine. Then simulate behavior module. Okay, let us complete the simulation behavior module. I think so you cannot see the module. Okay. So this window is the simulator window. Okay, here you can find A, B, and Y. So there is the methods to give the inputs. Okay, first is the test bench. Okay, that is bit hectic. Okay, just the same thing you can give from the keyboard also. So let us give force constant. Force constant, I will give it as a 0, apply 0, and B also force constant as 0, 0, apply. Okay, so it is just that means I have given two inputs A and B as 0, 0, and output is 0. Let us change the now A is 0 and B is also 0. So I will change the value of B to 1. Okay, so let us say 0, 1, it is 1. Okay, so similarly you can do for the all inputs. So here you can find all the input 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1. So this is the way we come OR gate. Okay, similarly you can do for the all the gates and just execute the outputs. Just what you have to give here is so just you need to change the code. Okay, while changing the code, let me change this. Okay, this is done. Yes, I want to close it. Okay, let me change the code. So, I will not change the code. I will create a new source. New source. I will write here as a VHDL module. VHDL module and underscore gate. Okay. So and gate next finish. Okay. Same way. The things. So new source. I will because we have not given our input and output here. VHDL module and underscore gate because already we have given the name. Okay, A. So A is an input, B is also an input, and Y is my output. Okay, next. So A pin is an input, B pin is an input, Y is an output. Okay. So same way, just write the behavior architecture. Behavior architecture will write it as Y implies Y is an output which implies equals A and B. Okay, the moment I write and it converts to blue. Okay, that means B then keyword. So let me save this again. I will save it. Okay, click here and get. Okay, and implementation part view RTL schematic. When you go to the RTL schematic, okay, it will generate the same schematic again. So let me so let me add the signal, add everything, click or create a schematic. Okay, this is an OR gate. Okay, this is RTL schematic. So you similarly you can see the view schematic, technology schematic. Okay, add and create a schematic. Okay, so here you can find okay the technology schematic. Okay, so next part is we will go for the simulation. So when you go for the simulation, click the simulation here. You want to go to the simulation, click behavior syntax check. Okay, it is done. Then go to the simulate behavior module. Okay, the moment you click behavior module, okay, so the new window is will get open. So let me share with you the I think ICM simulator window. Okay, ICM simulator. Okay, here this is your actual simulator. Let me show you again. Let me show you again. Okay, when you go to this simulator behavior module, this window will appear. So what are the objects name? So there is some problem. What is the problem? Object name. So input and output is not identified because we are working with AND gate. So we have not given anything here. Got me power. This is an AND gate. So we are simulating AND gate 1. Behavior syntax check. Simulate behavior module. Okay. The window is application window. Okay. So you can see now the so here you can find 0 0 is 0. Okay. So similarly we will give the all the inputs. Okay, and we will verify the our truth table. Okay. So let us make b as fourth constant 1. Apply. Okay. It will be 0 1. Okay. Fourth constant 1. Apply. Okay. And b is 0. Okay. So let us see with the 1 0 it is 0. Fourth constant last input is 1. Okay. So this is our all the inputs and outputs. So let me show you the all the inputs and output what we have given here. It is 0 0. So let us see. So for 0 0 it is 0. For 0 1 it is 0. Okay, let us go to the next. So it is not executed further. Okay. So 1 0. So let us change 1 0 and be finally fourth constant. I will change it to 1. Apply. Okay, then run this. Okay. So for 1 1 it is 1. So I will see how the input. So for 0 0 it is 0. For 1 0 it is 0. For 1 1 it is also 1. So this is the simulation for AND gate. Similarly, we will do the simulation for NOT gate. Okay, let me write the new source here. VHDL module NOT. Okay, that means inverter. Okay, next. So you have only one input and one output. So output is Y. Next, finish. So here one input and one output. So after begin, we Y implies equals A. Sorry, not of A semicolon. Okay, here Y. It is not no, it is not of A. So let us say this. So not of A is support A and Y the input and output. Only we are using not A here because only we have one input with an inverter. Okay, let us go to the implementation part. Okay, now we have not get as a top module. We set as a top module. Okay, so we are to schematic. Okay, add and create a schematic. So now this is not gate A and Y. Okay, this is the not schematic for the not inverter. So let us remove technology schematic. What is it? Yes. So this is my Node.js schematic. Anyway, if you click here, okay. So let us go to the simulation part. So when you go to the simulation part, first you have to just select here your source, that is not, okay, check syntax, okay, then simulate module. When you when you write simulate behavior module, so you the window, this window will appear for simulation, the simulation window. Okay, now you know a is constant, 0, suppose apply, so it will be inverted up. So force constant, if I give 1, the output will be inverted again. Okay, output will be 1. So this is what you have, 0 1 1 0. Okay, this is the NOT gate. Similarly, you can do for all the gates. Similarly, you can do for the all gates. Thanks for watching the video. If you have any comments, you can write me email or you can find the code. Thank you for watching the video.